non-infectious diseases of plants. Introduction. Non-infectious diseases, which sometimes arise very suddenly, are caused by excess, deficiency, non-availability or improper balance of light, air, circulation, relative humidity, water or essential soil elements. Unfavorable soil moisture, oxygen relations, extremes in soil acidity or alkalinity, high or low temperatures, pesticide injury, other poisonous chemicals in air or soil, changes in soil grade, gridling of roots, mechanical and electrical agents, and soil compaction. In addition, unfavorable pre-harvest and storage condition for fruits, vegetables and nursery stock often result in losses. The effects of non-infectious diseases can be seen on a variety of plant species growing in a given locality or environment. Many diseases and injuries caused by a non-infectious agents result in heavy loss but are difficult to check or eliminate because they frequently reflect ecological factors beyond human controls. Symptoms may appear several weeks or months after an environmental disturbance. Injuries incurred from accidents, poisons or adverse environmental disturbances often result in damaged tissues that weaken a plant, enabling bacteria, fungi or viruses to enter and add further damage. This cause may be obvious, but often it's obscure. Symptoms alone are often unreliable in identifying the causal factor. A thorough examination of recent weather patterns, the condition of surrounding plants, cultural treatments or disturbances, and soil and water tests can help reveal the nature of the disease. Let us now see the adverse environment. High temperatures may scald corn, cotton and bean leaves and may induce formation of cankers at the soil surface of tender flax, cotton and peanut plants. Frost injury is relatively common, but temperatures just above freezing may also cause damage such as net necrosis, that is localized tissue death in potato tubers and silvering of corn leaves. Isolated thin bark trees growing in northern climates and subjected to frequent thawing by day and freezing by night may develop dead bark cankers or vertical frost cracks on the south or southwest sides of the trunk. Alternate freezing and thawing, heavying, low air moisture and smothering under an ice sheet cover are damaging to the alfalfa, clovers, strawberries and grass on golf greens. Legume crowns commonly split under these conditions and are invaded by decay forming fungi. The drought and dry winds that often accompany high temperature cause stunting, wilting, blasting, marginal scorching of leaves and dieback of shoots. Leaf scorch is common on trees in exposed locations following hot, dry, windy weather when water is lost from leaves faster than it is absorbed by roots. Leaf scorch and sudden flower drop are common indoor plant problems because the humidity in a home, an apartment or an office is usually below 30%. Similar symptoms are caused by a change in soil grade, an altered water table level, a compacted and shallow soil, paved surface over tree roots, temporary flooding or waterlogged, which is oxygen deficient soil, griddling tree roots, salt spray near the ocean and an injured or diseased root system. Injured plants are often very susceptible to air and soil pathogens and secondary invaders. Blossom end rot of tomato and pepper is prevalent when soil moisture and temperature levels fluctuate widely and calcium is low. Poor aeration may cause black heart in stored potatoes. Accumulation of certain gases from the respiration of apples in storage may produce apple scald and other disorders. All plants require certain mineral elements to develop and mature in a healthy state. Macronutrients such as nitrogen, potassium, phosphorus, sulfur, calcium and magnesium are required in substantial quantities, while micronutrients or trace elements such as boron, iron, manganese, copper, zinc and molybdenum are needed in much smaller quantities. When the supply of any essential nutrient falls below the level required by the plant, a deficiency occurs, leading to symptoms that include stunting of plants, scorching or malformation of leaves, abnormal coloration, premature leaf or bud and flower drop. Even delayed maturity or failure of flower or fruit buds to develop and dieback of shoots can be seen. Symptoms of nutrient deficiency vary depending on the nutrients involved. The stage of plant growth, soil moisture and other factors, they often resemble symptoms caused by infectious agents such as bacteria or viruses. The availability of water may affect nutrient uptake by the plant. Blossom end rot of tomato, a disease associated with the deficiency of calcium, may occur if the water supply is irregular, even if an adequate amount of calcium is present in the soil. This discontinuity in availability of water will inhibit uptake of the calcium in a quantity sufficient to nourish a fast-growing tomato plant. Necrosis at the blossom end of the fruit results. This situation generally disappears when water conditions improve. Excess minerals can damage plants directly, causing stunting, deformities or dieback, or indirectly by interfering with the absorption and use of other nutrients, resulting in subsequent deficiency symptoms. A superabundance of nitrogen, for example, may cause deficiency symptoms of potassium, zinc or other nutrient elements. A lack of or delay in flower and fruit development and a predisposition to winter injury. If potassium is high, calcium and magnesium deficiency may occur. The pH of the soil has a dramatic impact on nutrient availability to plants. Most plants will grow in a soil with a pH between 4 and 8. In acidic soils, some nutrients are far more available and may reach concentrations that are toxic or that inhibit absorption of other nutrients, while other minerals become chemically bound and unavailable to plants. A similar situation exists in alkaline soils, although different minerals are affected. Oats planted in alkaline soils that actually contain a sufficient amount of manganese may develop the manganese deficiency disease grey speck. This occurs because an elevated soil pH causes manganese to react with oxygen to produce manganese dioxide, a form of the nutrient that is insoluble to plants. An excess of water-soluble salts is a common problem with houseplants. Salt concentrations may build up as a whitish crust on soil and container surfaces of potted plants following normal evaporation of water over a period of time. Symptoms include leaf scorching, bronzing, yellowing and stunting and wilting plus root and shoot dieback. Damage from soluble salts is also common in arid regions and in regions where ice control chemicals are heavily applied. Several non-parasitic diseases, example oak blast, weak neck of sorghum, straight head of rice and crazy top of cotton are caused by combination of environmental factors, that is high temperatures, moisture stress or poor irrigation practices, imbalance of mineral nutrients and reduced light. Environmental disturbances alter the normal physiology of the plant, activity of pathogens and host pathogen interactions. Let us see the high temperature disease. High temperature and drying winds can cause rapid loss of water. This moisture loss can cause premature leaf fall and leaf scorch. Leaf margins turn yellow or brown and leaves fall prematurely. You absolutely should water during periods of hot weather to prevent injury, especially smaller trees and new transplants. Plant trees in locations protected from prolonged exposure to sun and wind to prevent drying up. Low temperature disease. Frost injury can occur when a tree is growing during early fall or late spring and to freeze injuries or kill stem tissues. To avoid frost damage, plant locally adapted trees, cover trees if frost is expected, avoid frost-prone sites and lay off nitrogen fertilizer at the end of the growing season. Frost crack can cause serious damage to trees by lengthening already existing wounds after repeated freezes. What is a frost crack? Long vertical bulges or cracks on trunks indicate a recurring stress. The common term frost crack is misleading because frost or cold does not initiate a seam or a crack. It is, however, responsible for the continuation of a vertical crack. Cracks or seams start at wounds or branch stubs. Serious damage can result from seemingly minor wounds. A sudden sharp drop in winter temperature causes the outer layer of the wood to contract more rapidly than the inner layer, which can result in a long vertical crack at weak points in the trunk. Frost cracking can occur repeatedly in the same place, causing a buildup of tissues and the formation of frost ribs or seams. Depending on the tree species, the tissues at the margin of the injury may grow so rapidly that they curl into themselves, preventing complete closure of the wound. What do? Avoid wounds to the trunk and properly prune branches to prevent the formation of frost cracks. Let us now look at the excess moisture extremes. Roots in flooded or waterlogged soils are killed by lack of oxygen. Trees planted in heavy clay soils with poor drainage have the same symptoms. This oxygen deficiency resembles drought injury, including reduced growth, small leaves and thin crowns, twig and branch dieback and tree death. You can avoid problems if you choose wet tolerant tree species for moist sites or prepare the site to allow for adequate drainage. Let us now look at low moisture extremes. Drought symptoms can be seen when loss of water through the leaves exceeds uptake of water by the roots. This is caused by inadequate soil moisture during extended periods of abnormally low rainfall. Symptoms include wilting, off-color foliage, twig and branch dieback in the crown and the death of fine roots. You can avoid problems by not planting shallow rooted species in low moisture or sandy soils. Mulching the tree base retains moisture and a good weekly soaking during drought will also help. Toxic chemicals. Many complex chemicals are routinely applied to plants to prevent attack by insects, mites and pathogens, to kill weeds or to control growth. Serious damage may result when fertilizers, herbicides, fumigants, growth regulators, antidesiccants, insecticides, miticides, fungicides, nematicides and surfactants are applied at excessive rates or under hot, cold or slow drying conditions. Some pollutants are the direct products of industry and fuel combustion, while others are the result of photochemical reactions between products of combustion and naturally occurring atmospheric compounds. The major pollutants toxic to plants are sulfur dioxide, fluorine, ozone and peroxoacetyl nitrate. Sulfur dioxide results primarily from the burning of large amounts of soft coal and high sulfur oil. It is toxic to a wide range of plants at concentrations as low as 0.25 parts per million of air for 8 to 24 hours. Gaseous and particulate fluorides are more toxic to sensitive plants than is sulfur dioxide because they are accumulated by leaves. They are also toxic to animals that feed on such foliage. Fluorine injury is common near metal ore smelters, refineries and industries making fertilizers, ceramics, aluminium, glass and bricks. Ozone and peroxyacetyl nitrate injury, also called the oxidant injury, are more prevalent in and near cities with heavy traffic problems. Exhaust gases from internal combustion engines contain large amounts of hydrocarbons. Hydrocarbons are substances that principally contain carbon and hydrogen molecules. Gasoline, for example. Smaller amounts of unconsumed hydrocarbons are formed by combustion of fossil fuels, that is coal, oil and natural gas, and refuse burning. Ozone, peroxoacetyl nitrate and other oxidizing chemicals such as smog are formed when sunlight reacts with nitrogen oxides and hydrocarbons. This pollutant complex is damaging to susceptible plants many kilometers from its source. Let us now look at winter injury. Winter burn is a common conifer problem. Rapid temperature change on the south side facing the sun can cause needles to burn. Drying is caused by warm conditions taking tree moisture while frozen ground and tissue restrict plant water flow. Planting hardy trees, mulching, wrapping and avoiding areas with sudden temperature can help. Winter drying is caused by the desiccation of foliage and twigs by warm dry winds, when water conduction is restricted by frozen plant tissues or frozen ground. Reddening, browning and in some cases drooping of foliage becomes apparent in late winter and early spring. Often a combination of winter burn and winter drying will occur, occasionally complicated by drought. If severe enough, buds and later the affected branches may be killed. Sometimes the entire tree may also die. Usually only a few buds are killed and trees produce new foliage. Some conifer species are more resistant than others and should be planted where these conditions are common. How do you take care of this? Avoid planting ornamental conifers where sudden temperature changes may occur. Water and mulch around the trees in the fall to help prevent the soil from completely freezing in the rooting zone. Wrap susceptible trees in burlap during winter to reduce loss of water from the foliage. Plant seed sources that are hardy to conditions in the local area. Sun scald can occur in late winter or early spring when the temperature is above freezing during the day and below freezing at night. During the day, the tree tissues warmed by the sun become active. Freezing at night kills this tissue, resulting in an elongated canker usually on the southwest side of the tree. Thin-barked trees such as maples are most susceptible to this type of injury. How to overcome this? Shade the tree or use tree wrap on younger, susceptible trees to reduce the warming of the tree bark during the day. Plant susceptible tree species at closer spacing. Temperature too high is usually associated with high light, low relative humidity and or insufficient water. Usually high temperature and lack of water have similar symptoms. Dead, dry tissue that remains on the plant that can be easily broken. Usually young tissue is affected earlier than the old tissue. Let us now look at physical injury. Lightning, hail, high winds, ice and snow loads, machinery, insects and animal feeding and various cross-cultural practices may seriously injure plants or plant products. With the exception of lightning, which may cause death of trees and succulent crop plants in limited areas, such injuries do not usually kill plants. Wounds are created, however, through which pathogens may enter. Let us now look at chemical injury, nutrients and salt. Trees need certain nutrients for rigor and health. Nitrogen, phosphorus and potassium are the most important ones. Other major and minor nutrients are also essential. Lacking specific nutrients can affect tree growth and cause leaf chlorosis, yellowing and necrosis. One sure way to avoid having deficient elements is to take a soil analysis. Salt can cause injury in areas where road dicing is necessary. It affects foliage and can harm a tree over time. Chemical injuries which include herbicides and air pollution. Herbicide drift can injure trees. A deciduous tree leaf will become distorted, curled and brown on the margins. Conifer needles will turn yellow or brown and succulent shoots will become deformed. Trees may survive but growth will be stunted. Always follow the label and pick windless days to apply herbicides. Air pollutants emitted into the air from manufacturing and powder plants and automobiles can injure trees under certain conditions. They cause various symptoms and are hard to trace. Let us look at a little in detail about herbicide injury. Herbicide injury can occur either when herbicides are applied in the greenhouses where the crops are located or outside the greenhouse. Herbicide injury can be caused by direct application onto the crop or by persistence of herbicide in the soil affecting the following crop or by volatilization in closed environments. Talking about air pollutants, most pollutants are gases. Ethylene, ammonia, chlorine and mercury vapors are all possible problems in closed areas like greenhouses and storage facilities. Sulfur dioxide, ozone, fluorides and peroxyacetyl nitrate are associated with smog and can cause problems with plants outdoors. Unvented heaters and problems with the heater's exhaust are also very common in greenhouse industry. These problems are more noticeable in poly houses than in glass houses because poly houses are more airtight. Some symptoms of fume injury are top growth is deformed, there is stunted growth, epinasty, which is petioles and leaves bend downward. There can be flower bud abortion in some crops. Gas injury. Plants can be injured and killed by gases in the soil. Gases may be directly toxic or reduce oxygen to critically low levels. Natural gas is not toxic per se. Manufactured gas contains a number of toxic compounds. Gases produced by the decomposition of organic matter in the landfills can be toxic to plants in certain concentrations. Let us see the effect of low oxygen in the soil. Low oxygen is a consequence of waterlogging. It can be aggravated by high temperatures. Low oxygen also occurs in the interior of the fruits and tubers when the temperature is high. This situation is more common in storage. Let us see the effect of light. Lack of light produces etiolated, that is pigment deficient plants. Stretching can be the consequence of low light levels. Excess light is rare but may occur with indoor plants exposed to sunlight or plants grown in shade and suddenly exposed to sun. Now let us see the effects of water. Something so innocuous as water we drink can be a source of numerous problems in floriculture. Water related problems fall in three categories: too much water, too little water, problems caused by poor water quality. Too much water is very common in container grown plants. Too much water leads to a lack of oxygen, and anaerobic microorganisms produce nitrates that are toxic to roots. Roots lose selective permeability. How is this type of stress recognizable? Usually in overwatered plants drop lower leaves suddenly. They have leaves that turn yellow, they show black wet patches, roots or lower stem may turn black, may have succumbed to a disease, they also show wilting. The problem with this list is that many other diseases can also cause similar symptoms. Ultimately, questioning the grower and finding out what happened, for example, with the irrigation system will lead towards the cause. Too little water is even more of a problem on a global scale and very common with container grown plants. As with water excess stress, these symptoms are for the most part common to other problems, and ultimately they have to be complemented with more evidence obtained by questioning the growers, studying environmental records or inspecting irrigation systems. Poor water quality is a common problem in arid areas of the country and with crops grown in containers. The water characteristic that causes problems are electrical conductivity, which is greater than 1.5 meters, alkalinity, which is greater than 1.2 parts per million, too much of some element like boron or sodium. Let us now look at a little bit in detail about salt injury. Road dicing salt that is splashed onto foliage or is absorbed to the roots will cause a browning of the tree, especially on the side facing the roadway. Trees growing where salt accumulates because of drainage pattern will also be affected. The affected foliage will fall off in the spring, thinning the crown, although new growth will make the tree appear healthy otherwise. However, these trees will grow more slowly and remain stunted and may eventually be killed by prolonged exposure. Plant tree species which are resistant to salt injury to overcome this problem. Also, plant trees as far away from roadways as possible. Thus, these are the non-infectious diseases of plants. Thank you.